Welcome back. Problem 7-38. Statement is the beam is subjected to a shear of 2 kilonewton. Determine the average shear stress developed in each nail if nails are spaced 75 millimeter apart on each side of the beam. Each nail has a diameter of 4 millimeter. So you can see this is the beam that are built up by using woods through this nail on each of the sides. These nails are spaced part 75 millimeter and all the dimension, height, width, the width of this all are given, and diameter of each nail is 4 millimeter. So you have to find the shear stress, average shear stress developed in the nail. So let's start with the solution. So here we will use the equation of shear flow, which is horizontal shear force per unit length, or that is also equal to V into Q divided by I. So what we will do, we will find Q and I. So I is the section property, and you can see that if we take the half of this about neutral axis, it is not symmetrical, so we do not know I. So we do not know its location of neutral axis. So what we will do is we will find this y dash. So y dash is distance from neutral x, is the location of centroid neutral axis passing through centroid. So for that we have formula y dash is equal to sum of y dash into a divided by sum of area. So you can see we have, if we take this as 1 and these two are as 2, so this will be equal to y1 dash into a1 plus 2 times y2 dash into a2 divided by sum of areas, which is equal to a1 plus 2 times a2. So we will solve this. So let's take this base as a reference line. If we take this base as a reference line, clear? So what will be y dash? So y dash from this base till the mid of the first section will be equal to this y1 dash. This will be your y1 dash, and this y1 dash is equal to the half of this 50 is 25. So 200 minus 25 is 175 millimeter, and that in meter is equal to 0.175. So I will write y dash is equal to y1 dash, which is 0.175, and area of this first portion. So this area is 200 millimeter by 50 millimeter. So I will write them in meters. So 200 is 0.2 meter and 50 millimeter is 0.05 millimeter. Clear? Plus 2 times, now we have this area, this portion. So y2 dash is the distance from neutral axis till mid of this. Okay, till mid of this. So let this is your y2 dash. So y2 dash is 200 divided by 2, which is 100 millimeter, and that is equal to 0.1 meter. So I will write 2 multiplied by 0.1. Now area is, width is 25 millimeter, which is 0.025, and height is 200 millimeter, which is 0.2. Divide by a1. A1 was 0.2 multiplied by 0.05 plus 2 times a2 is 0.1 into, not 0.025 multiplied by 0.2. So when you calculate it, you will get y dash will be equal to 0.1375 meter, or that is 137.5 millimeter. So what will be the location of neutral axis from the from this base? It will be somewhere here. Let me draw it again correctly. So it will be somewhere here. That is location of neutral axis this I will show it like this. This is your y dash, and y dash is, this is your neutral axis. Now we'll find I for neutral axis. So we know that by using parallel axis theorem, it will be sum of I dash plus AD square. So we will first take this first portion, I, this first one, clear. So 1 over 12, breadth is 200 millimeter, which is 0.2, and thickness is 50 millimeter. Our height is, so it's 50 millimeter is 0.05 whole cube plus AD square. So area is 0.2 multiplied by 0.05. And what about D? So D is distance from neutral axis till the mid of this section. So this will be your D1. This will be your D1. So D1 is, you can see that this is y1 dash minus the half of the y1 dash 0.75, this y dash 0.175 minus this y dash, and this y dash is 0.1375. So I will write it down, multiply by 0.175 minus 0.1375 whole square, plus we will find the moment of inertia for second part or second member. So 1 over 12 2 times, because we have two members, so 2 times moment of inertia of 1 over 12. B is 0.025, this one, and height is 200 millimeter, which is 0.2, clear, whole cube, plus AD square. So area is 2 times 0.025 into 0.2, and what will be its D2? So D2 is actually 0. This distance is your D2. This is your D2, which is equal to y dash minus y2 dash. So I will write it as y dash is 0.1375 minus y2 dash is 0.1 whole square. So when you solve this, you will get the moment of inertia of this cross section about the neutral axis comes out to be 63.5417 into 10 raised to power minus 6 meter power 4. Now you have I, clear. We will move toward finding Q. So Q, so what will be the shaded area for the Q? So you can see the nails are over there at this points, clear. So horizontal shear force will occur at these regions, so this will be your shaded area, and we will find Q for this shaded area. So we know that that is equal to A into y dash. So area of this shaded portion is 200 into 50 millimeter. So 0.2 in meter, it is 0.2 into 0.05, clear. And what will be the y dash? So y dash is distance from the center of this member till the neutral axis, which is D1. So D1 was 0.175 minus 0. I will write 0.175 minus 0.1375. Okay. So when you solve this, you will get Q will be equal to 0.375 into 10 raised to power minus 3 cubic meter. Okay. Now what we will do is that we know that shear flow, which is equal to horizontal shear force per unit length, since there are two rows of nails, one on this side and other one is on this side, clear. So we will multiply it with 2. So shear flow is equal to 2 into F divided by S, and what we will do is that this Q is equal to 2 into F divided by S is given as 75 millimeter. So that is 0.075. So that will give you 26.67 times F, and the unit will be in Newton per meter. So shear flow comes out to be 226.67 multiplied by F. Clear? Unit is Newton per meter. Also, we know that shear flow is equal to Q into V divided by I. Clear? So you can just put the value of this shear flow, which is 26.6 times F, is equal to V. V is not 2 kilonewton. So 2 into 10 raised to power 3. Q is 0.375 into 10 raised to power minus 3 divided by I, which is equal to 63.5417 into 10 raised to power minus 6. Okay. Now from here you will get this horizontal shear force is 2 into 10 raised to power 3 multiplied by 0.375 into 10 raised to power minus 3 divided by 63.5417 into 10 raised to power minus 6 multiplied by 26.67. So when you calculate it, you will get this F is 442.62 Newton. Now this is the horizontal shear force, clear, acting on that. So what we will do, we are interested to find the shear stress developed in the nail, which is shear in nail, which is equal to horizontal shear force per unit area. So 442.62 divided by diameter of nail is given. So area is pi by 4 into 0. Which is 4 millimeter. So in meter it is 0.004. So pi by 4 d square. So when you solve this, you will get the shear stress in the bolt or nail is 35.22 into 10 raised to power 6 Pascal, or you can say the shear stress developed in the nail is 35.2 megapascal. Okay. And this was all about this problem 7-38. I hope you have enjoyed the video and you have learned from it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.